In this section, we will simplify radical expressions. Now, we've talked about perfect cubes and perfect squares before, and those concepts were previously introduced when you were learning the difference of squares and the sum and difference of cubes. Squares. It will be to your advantage to memorize the first 10 perfect squares. Now, here we have on this side the perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and it continues to go on and on forever. And also we have the radical symbol. Notice that there's an index that's in red here. And you have a radical symbol, and then what's under the radical, this B is called the radicand. So whatever is under the radical is called the radicand. You have a radical symbol, and your index is that number that's considered to be here. Now, if it's the square root, then nothing will be written here. So, for example, if you look over here to the right, you'll notice that we have the square root of 1 and nothing is inside of that little V part. So it's understood to be a 2 there. So we have the square root of 1. It equals 1 because 1 square is 1. The square root of 4 equals 2 because 2 square is 4. The square root of 9 is 3 because 3 square is 9. The square root of 16 equals 4 because 4 square is 16. So, what is the square root of 25? 5, for example. Or if I ask you, what is the square root of 100? What square is 100? 10. Or if I ask you, what is the square root of 225? And try to figure out what symbol or what button to use on your calculator for these particular examples, because that would be the easiest thing to do, is to find your square root symbol on your calculator. Again, in the square root symbol, what is the index considered to be? So for square root, it would be 2. It's considered to be 2, although we don't actually write the 2 here, but it's considered to be a 2 there if nothing is there. And it's the square root symbol. Now we also have cube roots. You're actually going to see a 3 if it's the cube root. The fourth root, you're actually going to see a 4 in those cases. All right, let's move on. The product property of radicals. If you have what we consider to be multiplication under the radical, you can split up that one radical into 2 radicals. So the nth root of b times c equals the nth root of b times the nth root of c. These are equivalent. So it's best that we just get to an example so you can see. Now, let me read this first. A square root is considered to be its simplest form when the radicand, what is the radicand? It's what's under the radical, has no perfect square factors other than 1. So let's get started with the square root of 4 times 25. Square root of 4 times 25. There are 2 ways you can get this done. One way is to split up using the product property of radicals. You could split this up as the square root of 4 times the square root of 25 and simplify each one of these radicals individually, because the square root of 4 is a perfect square. It's on our list of perfect squares. And what is the square root of 4? It is 2. Also, the square root of 25 is 5. So 2 times 5 equals 10. So that is one way you could have done this problem. But also look at the fact that 4 times 25 is 100. So we could have written this as the square root of 100, which also equals 10. So two different directions there. Now let's move on to the square root of 72. 72 is not on our list of perfect squares. This is a case where you will have to, so as you can see, 72 is not on our list of perfect squares. 72 is not on our list of perfect squares over here. So this case, the rule is if there is a perfect square factor in 72, we must simplify it. So what perfect square on this list divides into 72? And we're looking for preferably the largest perfect square so that we don't have to simplify over and over again. If we take the largest perfect square that is a factor of 72, then we lessen our workload. Okay, so it turns out 36 can divide into 72, correct? So 36 times what is 72? So we're going to rewrite this square root of 72 as 36 times 2. Square root of 36 times 2. That way we can split it up as the square root of 36 times the square root of 2. And what is the square root of 36? It is 6. Therefore, it's not under the radical anymore because 36 was a perfect square and the square root of 36 is 6. However, 2 is not a perfect square. It remains under the radical. So square root of 72 simplifies to 6 times the square root of 2. And you can check that. You can put the square root of 72 in your calculator to see what that decimal is. And also 6 times the square root of 2 in your calculator to see if those two are equivalent. Moving on, we have a negative square root of 16. Now that is like negative 1 times the square root of 16. Notice that the negative is not under the radical. It's on the outside of the radical. So we're just going to simplify the radical and multiply it times that negative 1. Now the square root of 16 is 4. So therefore negative 1 times 4 is negative 4. Moving on with the square root of 8. Now is 8 on our list? Now if you think it's on our list but it's not, because square root of 4 is a perfect square and 9 is a perfect square but not 8. However, does 8 contain a perfect square factor? Actually, 4 times 2 is 8. So we're going to break it up into two radicals and we're going to simplify each radical individually. The square root of 4 is 2, and then you have the square root of 2, so that it simplifies. Square root of 8 simplifies to 2 radical 2. Moving on to 50. 50 is not on our list, so it's best to have your list ready so that you can look at it. So 50 is not on our list, but which one of these other perfect square factors can divide into it evenly? And we come to the conclusion that square root of 50 is the same thing as square root of 25 times 2. We can split that up into two radicals and it simplifies to 5 times the square root of 2. Moving on to 216. What perfect square divides into 216? So it's best that you go ahead and pause the video. So go ahead and pause the video to see if you can figure it out. So if you said the square root of 36 times 6 is square root of 216, then you are on the right track. 36 is the largest. Now again, let me reiterate, you want the largest so that you don't have to simplify your answer more than once. So if we split this up, we get 6 times the square root of 6. What about the square root of 45? What perfect square divides into 45? 9. So we can split that up as the square root of 9 times the square root of 5 to get 3 radical 5. And notice the next one, we have a 5 on the outside. What does this 5 on the outside mean? It's just 5 times the square root of 180. So it really doesn't mean anything other than this is being multiplied times 180. Now, what perfect square factor divides into 180? All right, so 36 times 5, and then 5, we have a square root of 36. So I'm going to start splitting it up. You can split it up, but I know that the square root of 36 is 6. So I can bring that down, and it leaves me with a square root of 5. So the final answer is 30, because 5 times 6 is 30 times the square root of 5. 30, or 30 radical 5 for short. Now we have 3 times the square root of 80. Now what perfect square, but what is the largest perfect square that can divide into 80? So 16 times 5 is 80. Again, you can split that up if you wanted to, or go right to 3 times 4 square root of 5, since the square root of 16 is 4, and 3 times 4 is 12 square root of 5. So 12 times the square root of 5 is the final answer. Then we have negative 90. So that's, again, like negative 1 times the square root of 90. And I know that 90 is 9 times 10. So that's negative 1 times the square root of 9 is 3. So the final answer is negative 3 times the square root of 10. All right, what about the square root of 48? What perfect square is in 48? All right, so is it 16? 16 times 3. So the square root of 16 is 4, and we just bring down the square root of 3. So 4 times the square root of 3. Now let's look at this last one here, the square root of negative 16. There's no number that I can square to give me negative 16. So this is when they say write it as not a real number. Okay, it's not a real number. This is when we go off into imaginary numbers, and you will eventually get to that, solutions to that, but for now you're going to say it's not real. Okay, moving on, when dealing with negative numbers and radicals, the only restriction concerns negative numbers under even root. So if you have a negative number under an even root, then we say that there's a restriction there, and for now, for the most part, we're going to move on. And what do we mean about even root? That was a square root. Now with cube roots, you can have a negative number under cube roots because that's an odd root. All right, if an integer is not a perfect square, its square root can only be approximated. For example, what is the square root of 3? Now, we can't simplify that into another form, but we do know what it is based on our calculator. Now, if you put the square root of 3 in your calculator, what would you get? All right, and here I say use a calculator to approximate to three decimal places, and that means you want 3 numbers behind your decimal place. Always remembering that you have to round if necessary. Okay, so here we have square root of 3. You put that in your calculator, you're going to get an approximate answer of 1.732. Okay, and in your calculator you should see 1.732050808. Now, since that 0 after the 2 is not 5 or higher, then you will not round up. What about the square root of 79? Square root of 79 is 8.888. All right, again, we will not round up since the 1 after that 8 is not 5 or higher. And then you have the square root of 123. The approximate answer for that is 11.091. And we put 1 there because that 5 right after the 0 is a 5, okay? So if it's 5 or higher, you will round up. Next, true or false? Is the square root of a plus b the same as the square root of a plus the square root of b? And I have some numbers here for you to prove or disprove it. So let's do the left side first. What the square root of a plus b is if a was 16 and b was 9? Well, if we make that substitution, let's do the left side over here and let's do the right side over there. So 16 plus 9. What is that? 16 plus 9. So that's the square root of 25. So the left side equals 5. But on the right side, the square root of 16 plus square root of 9, is it the same? Now the square root of 16 is 4 and the square root of 9 is 3. So on the right side we have 7. Now 5 does not equal 7, right? It does not equal 7. Therefore, the square root of a plus b does not equal the square root of a plus the square root of b. So as long as you know that, it seems tempting that they are equivalent, but they are not equivalent. Now let's talk about cubes for a second. Cube roots work the same way as square roots, but notice the numbers are slightly different. Now 1 is also a cube root because 1 cubed is 1. 8 is a cube root because 2 cubed is 8. Then we have 3 cubed and 4 cubed and 5 cubed and so on. When you have a radical, the main difference is the index is considered to be 3. And you're going to see the 3 for cube roots. Let's move on to an example. We have the cube root of 8 times 27. Again, you can split that up into 2 radicals, the cube root of 8. Remember, you got to put that 3 there though, times the cube root of 27. And what is the cube root of 8? Or in other words, what number cubed is 8? And that would be 2. And then for the cube root of 27, that would be 3. So 2 times 3 is 6. Again, you could have done that differently. You could have multiplied 8 times 27 first and figure out what the cube root of that product is. And then let's move on to cube root of 54. Now, we're not looking for perfect squares anymore. We're looking for what perfect cube can divide into 54. Can 8 divide into 54? No. Can 27 divide into 54? Yes. So we're looking for perfect cube factors of 54. So we can break it down as the cube root of 27 times 2. And then again, you can break this up into 2 radicals according to the product rule of radicals. Cube root of 27 is 3 times the cube root of 2 because you can't break down the cube root of 2. So that is your final answer. Let's move on to the cube root of 108. What perfect cube factor can divide into 108 evenly? All right, again, 27 can divide into it times 4. So we can break it up as the cube root of 27 times the cube root of 4. And then you have 3 times the cube root of 4. Root of 24. We have the cube root of 8 times 3. And again, cube root of 8 equals 2. And then you have the cube root of 3. Alright, what about negative cube root of 8? Again, that same thing is negative 1 times the cube root of 8. We know that the cube root of 8 is 2. So our final answer here is negative 2. Then we have the negative on the outside. You have the cube root of negative 8. What is the cube root of negative 8? Let me write that back over. Negative 1 times the cube root of negative 8 is negative 2, because negative 2 times negative 2 times negative 2 is negative 8. So that's why I said earlier that you can simplify when you have an odd root, which is 3, odd numbers like 3, but you can't do that if it was a square root. So negative 1 times negative 2 is positive 2. Moving on, the square root of a squared, that is, square root of a squared equals the absolute value of a, because we don't know if a is negative or positive, so that's why they said the absolute value. Now, I'm not going to go over that. We're just going to simplify this without worrying about the absolute value symbol. So the square root of a to the 6th power. Well, since we know that the square root of a squared is a, then since this is a square root, or this is considered to be a 2 here, you could just divide 2 into 6, and that will be to the 3rd power, right? But I'm also going to show you how you can break it down. You can break it up as a to the 6th is the same as a squared times a squared times a squared, correct? And then we know that the square root of a squared is a, another a, another a. And what is a times a times a? Is a to the 3rd power. So that's one way of doing it. Square root of square root of 8x cubed. Again, we know that square root of 8 is 4 times 2. Now with x cubed, there's an x squared in there, but then there's a remaining x. Now what you can do is put some space in the front, and we're going to go down the line. The square root of 4, what is that? That is 2. So that goes outside of the radical. However, this 2 right here stays under because you can't simplify it. The square root of x squared. This square root of x squared is x, so that goes outside. However, this x right here stays on the inside because there's not enough x's. So this is your final answer. Moving on again to the square root of x to the 7. Again, you could take a shortcut route and divide 2 into the 7 to give you 3, and you have 1 remaining. That 1 remaining will stay under the radical. Or you can break it down like this. Square root of x to the 7 is x squared, x squared, x squared, but you have 1 remaining. Again, we're dividing by 2 because it's a square root and it's considered to be a 2 as the index. But you can also break it down like this. What is the square root of x squared? Is x. Square root of this x squared is x. Square root of this x squared is x. But this is not enough, so you got an x on the inside remaining. This one remains under. And then what do we have when we bring it all together? X cubed times the square root of x. Moving on to square root of 24x to the 5th. 24, we have a 4 times 6, and then you have an x squared, x. Now what goes on the outside? Well, the square root of 4 is 2. However, that 6 stays under. The square root of x squared is x. The square root of x squared is x. So x times x is x squared on the outside. But again, that x on the end stays under. Then we have the square root of 4 to 5, x to the 4th y. That's 9 times 5, x squared, y. So square root of 9 is 3. We're going to leave the 5 under. Square root of x squared times square root of x squared. Well, that's going to be x squared on the outside and y under. Let's go to negative 4, square root of 20, a to the 4, b to the 7. So that's 4 times 5. Then you have a squared. But for the b, you have a b squared times b squared times b squared times b. Now you have a negative 4 on the outside. Don't get too anxious about that. We're just going to multiply what we put on the outside times that negative 4. So the square root of 4 is 2. Let's put that on the outside. 5 stays under. And then with this, you're going to end up having a times a, which is a squared. And then with this, you're going to end up having b times b, which is b cubed. And then you have 1b remaining. Now when you multiply this together, you get negative 8a squared b cubed times 5b. Moving on, notice now we've switched the cubes. So we got to think in terms of perfect cube factors. So 40, what perfect cube factor divides into 40? Now if you said 8, you are on the right track. And then, since we're dealing with cubes, we're going to break things down into cubes. So instead of x squared now, we're going to put x cubed. And we're going to try to put as many x cubes as possible. X cubed times another x cubed times x. And what about y to the 8? Y cubed times y squared. All right. Put some space in front of your radical, and we're going to go down the line. Cube root of 8 is 2. So it goes on the outside, but the 5 stays under. Then you have all of this. So that would be x cubed on the outside, but you have 1x on the inside. And then you have y cubed times y cubed here, but the cube root of y cubed is y. The cube root of another y cubed is y. So y times y is y squared on the outside. But you still also have that y squared on the inside. Next we have cube root of 54x to the 6. So that's cube root of 27 times 2 times x cubed times x cubed. And then you're going to take your 3 out, leave your 2 under. And then the cube root of x cubed is x, cube root of another x cubed is x. So that's x squared on the outside. And then you have this big number of 250 that you have to figure out. What perfect square or what perfect cube divides into 250? And I guess the obvious number is 125. So we have the cube root of 125 times 2, a cubed, a squared, b cubed times b cubed times b cubed times b squared. The cube root of 125 is 5. Leave your 2 under. Then you have a squared on the outside, a squared on the inside. So a squared came from this because a times a is a squared. But that a squared stays under. Then you have b cubed that's going to go out here and b squared that stays under. Now here is a challenge. I want you to pause the video, see if you can simplify these two challenges. Okay, so if you're done, then let's proceed. I'm first going to rewrite this outside radical back over, and then square root of 81, doesn't that simplify to 9? So now you have the square root of 9, which equals 3. It was as simple as that. All right, next you have square root of x squared plus 6x plus 9. Well, if you have factored that, you would have realized that you have x plus 3 times x plus 3, which is x plus 3 squared, right? And there's a rule, and you're going to learn about that a little later, where if these numbers here are the same, then they are inverses of each other. They cancel each other out. So what's the square root of x plus 3 squared? It will just simply be x plus 3, because x plus 3 squared equals x squared plus 6x plus 9. So this answer just simplifies to x plus 3. Now this concludes the lesson on 9.1, Introduction to Radical Expressions.